drainage improvements would be required in order to build that site access road down in that area. Again, not necessarily the most desirable option, so we haven't pursued that, looking at that any further. Another option is a traffic signal. We talked to the city, and they said that it could be warranted due to the line of sight issue and the potential impacts to the water mains. There would be a sign there that said, "Prepare to stop when flashed." So you're basically telling that traffic, hey, the light's red, stop when you're approaching. So that's going to give us our best chance under this scenario to slow that traffic down and make them stop and make that turning movement at your driveway safe for traffic entering and exiting the site.
It's not just the the small vehicles too. That's got to be a little issue for when we get deliveries of larger trucks. Is that?
Well, there is a. I mean, I don't know about the traffic patterns.
Yeah, we get tankers, dual tankers come in. Go use that driveway.
Yeah, I didn't know if they use the western driveway or.
They come in the west. They'll make the delivery and then
come back up.
East.
Right.
Yeah.
So
You're not stopping traffic. You're not making traffic come to a stop, but you're significantly slowing them down with a roundabout. The city thinks that this would be the best ultimate solution to the problem. That was kind of their comments. Again, because of the vehicle speeds and the line of sight issues associated with that, we would put in advanced flashing beacons warning people of a traffic pattern, slow down. And then the first few cars that come through there and don't know it's there, they're dropping axles going across it. Once they learn it's there, everybody will slow down and go through the roundabout in a more appropriate speed. One of the things a roundabout will do, because it slows traffic down, if there is an accident, there's minimal property damage. You're not going to get the T-bone. You're going to get a glance and blow type accident. There would be some significant street improvements because we tear up the entrance, we put in a bunch of medians and kind of change the pattern. This is a concept of what a roundabout would look like at the intersection. The gray areas would be your raised median, in a matter of speaking, and what we would do is we have some traffic lanes going around there, and then we'd also incorporate what we call truck aprons. The first outer circle of that intermediate is a mountable curb, so that trucks, their rear axles can actually jump up on that median because their turning radiuses are such that they need a little more space to turn through there. And then the center median's a barrier type curb that is designed to keep people from just driving straight through there. So this would be a concept of what a roundabout at the driveway would be. So there wouldn't be a specific requirement to actually stop any vehicles if you're just slowing the traffic down to a more appropriate speed. Maybe, I would hope maybe in the 30-mile-an-hour speed range, 35 or something, coming through that instead of going through there at 70 miles an hour. Now, the other thing is people don't like to drive around it. They're not going to come flying around that corner. They're going to take a different route. So you will reduce some of that traffic on the street. Due to the non-compliant line of sight, the city is going to require that this condition be resolved. We're going to have to address the line of sight issue for that entrance. The first solution, as I mentioned earlier, would be to modify the vertical alignment avenue, and that may not be desirable due to the potential impacts of existing water mains. A traffic signal or roundabout would be the best alternative solutions. The traffic signal, again, costs maybe a little bit more. Roundabout is better to slow traffic, enhancing safety. The City of Palmdale will support either of those two solutions if the board wants to go that way. I didn't have any specific recommendations for the board. I just wanted to present this information to the board. I've got a lot of information here, so I'm going to move through it fairly quick because it does take some time. But please feel free to stop me and ask any questions along the way if you have any. The consultant services basically will consist of the construction drawings and improvement plans. There's building design services, including the LEED certification. There's site civil plans, including on and off-site improvements. There's bid assistance, there's construction services, and there's commissioning. Commissioning is a requirement of our LEED certification. Without the LEED certification, we probably wouldn't be into the commissioning, but since we're going after the LEED certification, we have to have the commissioning. Under the construction drawings, architectural plans, there's title sheets, site plans, ADA facilities, that's the handicap, parking facilities, path of travels, floor plans, ceiling plans, door and window schedules, interior and exterior elevations, building sections, roof plans, chemical and hazardous material analysis, that would be for the laboratory. There's construction details, again, handicap parking and general notes. That's in your construction drawings. We have structural drawings and calculations. That's the calcs, the foundation plans, floor and roof framing, shear diaphragm, shear walls, construction details. Electrical drawings, we have power supply, lighting, panel schedules, signal line diagrams, lighting controls, general notes. Provisions for low voltage systems, we put in conduits, junction boxes, mud rings, etc. We provide those provisions, then you would have another contractor, design build contractor, that would come in and specify all the equipment and everything else, but we would make provisions available for them. Same thing for the solar, for the future solar connections. We would put conduit in and also provide space in electrical room for the future solar. The mechanical drawings would consist of the HVAC system and equipment plans, duct sizes and locations, supply and return air registers, equipment schedules, details, and general notes. Plumbing drawings. Plumbing drawings would include gas. The gas system is the building supply, as well as a laboratory system. There's going to be gas piping throughout the lab because they do use gas for various testing procedures within the lab. Then we also have water for the building, sanitary waste, ventilation for the building, HVAC, condensate and roof drain piping, fixture schedules, isometric diagrams, installation details, and notes. Title 24 Energy Code Compliance Documentation. This is for the building envelope. This would include the HVAC system as well as the lighting system. Then we get into project specifications that we would prepare for the project. They do book form, CSI format. LEED certification and documentation. That would be the silver or gold level. We're going to pursue the gold level. We don't want to say for sure that we're going to achieve that gold level, but we know we can get. We're pretty confident the silver level is not going to be a problem. We're pretty confident we can even get to the gold level. The services there include project registration, minimum program requirements, scorecard tabulation, energy modeling, commissioning. The commissioning would be the design phase services, and that would be handled by another consultant. We have a compressor or condenser for this building that's down there that has to get relocated. There's existing fencing has to be removed, and there's an existing sewer line and some other utilities that run underneath that pad. All that has to be moved before we can start any other construction in that area. Dimensional control plan, which is the site geometrics and dimensions, orientation of the building, how far away, basically establishes precisely on the site where the improvements are. We get into the grading plans, that's the vertical control grades and elevations, pad and finished floor elevations, cross sections of the site, on-site construction details, remedial earthwork, that's the over-X under the building. There's stairs, steps, seat walls, ramps, railings, general notes and construction notes. There'd be an on-site storm drain plan. There is going to be some small storm drains, which we have some catch basins, mains and laterals, as well as some stormwater mitigation facilities, which will mitigate our stormwater runoff. Our first flush basically keeps the pollutants out of our, as required. We have an on-site utility plan that would be sewer laterals to the building, domestic water supply to the building, site lighting locations, photometrics to make sure that we meet photometric requirements of the city of Pondale, and dry utilities, that would be the electric, water, and gas. All those would be supplied from the plant, so we will coordinate the connection locations with staff where we're going to get power and gas and water for that. We'd have a fencing and wall plan, which would be layout of new site fences and walls, construction details, fence footings, gates, gauge tracks, retaining and screen walls. We will have some retaining walls, etc. on that. We'd have an on-site septic system plan. As you may be aware, the existing septic system is not in size large enough, so we're going to replace that septic system. with this. So there'd be a plan and profile of the piping system, as well as tank and leach field layouts, holding tank and interceptor as needed. We're not quite sure what we're getting into with the lab, what kind of chemicals might be dumped down those sinks. So, as we get into the design, we may end up with some kind of interceptor or holding tank associated with the lab drains.
I know you talked earlier, I don't know if it's here or the other, both or whatever, about dual plumbing and possibly a gray water system. Would that fall
Yes.
into this part?
Yes. That would be, and I apologize, in my
I know
notes.
it's plumbing and this, so.
Yeah, it would be on the plumbing plans, and that would be also included with, once we exit the site, where we go with those. In all likelihood, we're probably manifolding together until we have some other place to take that. Yeah. The stormwater pollution prevention plan, which is required, that's sandbags or silt fence layout, best management practice for the construction activities, notice of intent to be covered under the state's NPDES permit, and everything's electronically submitted to the state now. We prepare these things, and we have to get an account on the state's website and upload all these documents to their website. There's a paving plan that would just be the structural sections for the various pavement around the site, as well as any decorative paving, hardscape call-outs, any sidewalks and so forth that we have around the site. We have an on-site fire protection plan. The first item here is the alternative means and methods report. I want to bring this up because we don't have a standard public water supplier that would be supplying fire protection for this site. So the site is basically a private water system, and we will need to go through this alternative means and methods report with the fire department. Basically what we do is we have to give them details of what where are we getting the water, how is it supplied, what's pump capacities, do we have emergency power, what's the storage capacities. Storage for fire flow must always be available. It cannot be part of the operational storage. So in a lot of instances we don't have 12 million gallons of storage at our disposal, but if we're talking about a 500,000 gallon tank, we got to make sure that we have alarm systems and everything, and make sure that we have half of that available for fire protection or whatever the volume of storage is required. Somehow we have to justify that to the fire department so they realize that their fire protection system that they're responsible for meets all their requirements and is adequate to provide fire protection for this site. So that's just an extra step of going through that we have to go through, because this is a private water system that we're using for fire protection of the facility. Other items through the fire protection plan is just the on-site fire hydrants, on-site mains and laterals, post indicator valves, fire department connections to energize the sprinkler systems if everything else fails, hydraulic calculations for the systems and typical details. We do an on-site signing and striping plan, which would be parking stalls and handicap spaces, path to travels, and fire lanes around the building. We'd have a landscape and irrigation plan. We do water allowance and usage calculations. The state mandates what our water allowances are for landscaping, so we have to go through those calculations and show that we're using less than what's allowed. Then we do an initial planting plan for the owner's approval, construction documents, planting and irrigation details. Off-site improvements as needed. This comes back to what are we going to do to resolve the line of sight issues. If we're putting in a traffic signal, we're having some pavement transitions for the left turn lane. If we're doing a roundabout, we're going to do medians, pavement transitions, etc. We're going to do some removal and reconstruction of existing pavement to do vertical alignment. But as of tonight, we're going to set that one aside. We're not going to explore that one any further. The new driveway approval. If we relocate the driveway, there will be some improvements for a new driveway. Along with that, we need to do a sign-in and striping plan, traffic signal plan, if this is the option we go with, sections, which would be on your high-strength masonry, post-installed anchors, field welding, moment frames, a geotechnical engineer to do compaction testing, grading control, and material testing. There'd be a lot of material testing for concretes, because most concrete's all going to be over 3,000 psi, and so that all has to be tested. Land surveyor that would do the construction staking, commissioning. we talked about commission briefly earlier, design phase costs, there'd be the entire building startup, which is HVAC, controls, electrical, mechanical, HVAC and automated control system, electrical systems, energy efficiency measures. There's a lot of stuff the commissioning agent would get involved with. The first stage obviously is the design phase, but really their services really come into later when the construction is done. This is an estimate of our consultant fees. Our base fees are basically, without knowing what we're going to do with the offsite improvements, so that's the base fee. Building design services, we've estimated to be about $175,000. That's for all the services that we outlined previously. The site civil plans would be about $85,000. Bid assistance would be about $15,000, and then the construction services would be about $75,000. It gives us, for those services, gives us a subtotal of $350 grand. Now we have other consultants, and this is a budget. I've talked to some of these other consultants, so these numbers should be in the ballpark. Special inspections would be about $7,500. Surveying could range up to about $12,500. Geotechnical, mostly because of the material testing and compaction testing, they estimated about $30,000, and the commissioning consultant estimated also about $30,000 for his services. And then for other consultants, you would approve this is a design phase commissioning fee estimate of $7,500. This is an estimate that the commissioning agent has provided to us that they feel during the design phase that this would be a good budget for them, their services during design. The estimated total was $300,000 for approval at this time to cover all the design and plan, to prepare all the plans and process the plans with the various agencies and get plan approvals, and to the point that you could actually get ready to go out to bid. This does not include the bid assistance and moving forward from that standpoint. You will note the $117,000 for the site civil plans was the higher number for the line of sight resolution, because we don't know where we're going with that yet. And I didn't want to get a lower number approved and then end up having to come back to get a higher number approved, because we've changed gears and gone at, and went to the roundabout, which would require more design time. So this is our recommendations to the board. So we're asking the board to give us approval for this estimated amount to basically proceed with the design of the operations center.
Can you hear me on the phone? All right, no problem. So there's 2 wells proposed on this 80-acre bench ranch site, shown on the right half of the figure. And there's a 3rd well on existing property that you own, 80th and H. I'll show those in more detail. So this is just an overview. And Ben's going to talk a little bit more about the pipeline in the report tonight as well. In the center of the bench ranch property are some remaining structures. We purchased this property. It was a prior horse ranch. So there's an old dwelling and some outbuildings and some stables, and they've been marked as potential for demolition. They've been covered in the secret documents. They're currently not in our contract for them to be demolished at this time, but you can demolish them at any time that you choose, based upon the fact that you've got them covered in the documents. So we'll touch upon that too. The 3 wells, this is their design criteria. They range between 450 and 550 feet deep. They have 14-inch casings to be equipped with 200 horsepower vertical turbine oil pumps. They would pump between 1,000 and 1,100 GPM as their target capacity. When they operate over the year, they tend to operate between 80 and 90%. So it's an estimated 87% operations if you would basically run them continuously, so on and off periods. The bottom level shows the average gallons per minute, or GPM, ranging from 875 to 962 gallons per minute. And that's what we put in the model run that we show you the results for in a moment. If you run those 3 wells at that capacity all year, you would produce 4,500 acre feet of water supply. It's proposed that the buildings, that the wells be enclosed within buildings. These are roll-apart buildings, where half the building, like the clamshell, rolls away so that a well driller can have access to pull the well for maintenance in the future. So half the building is stationary and half the building rolls apart. This is a picture of a 14 by 26 foot roll-apart building. It's made by a company whose name is Roll Apart. Kind of cute, right? They have supplied a number of these to my previous employer at Riverside. This one is called, this is at Flume 7. That has inside a 2 horsepower well pump, just as we're planning here. There's a plan view and a section view on the lower left of the drawing here, just to give you an idea that in one room there is the well pump on the well concrete base, and in the second room are the electrical panels and the supporting RTU, which is the remote terminal unit that has in it the communications that would send information back to your SCADA system. So typically operated would enter into that electrical room and then continue on and enter into the pump room. The pump room is just both rooms are just ventilated, they're not HVAC, so installed at Riverside. And so basically you could order that third building to have this appearance so it would match the existing buildings on the site. So other design features, we plan to fence the sites for security as well as have the buildings and potentially cameras, video cameras on the site. So several means of security to protect these wells. For the 2 wells that are proposed on Bench Ranch, we would have a 100-foot square with a 7-foot chain link fence with barbed wire, the same as we've done on the other well sites for the agency. The third site has a little bit different shape, but it would also be proposed to be fenced. The Bench Ranch site, we're proposing to have 2 access roads, one in front of each well that goes directly north to West Avenue Ridge. And they would be not paved, but they would be all-weather base paved, left an intermediate level of expense between a dirt road and a fully paved road, and that works well at other district sites. So that's the plan at this point. On the east portion of this site layout is a blow-off pond. So when the well started, it's blown off. It blows off to a small pond that's about 24 by 90 feet. It's within the fenced area. Chain link fence is a double gate for when staff and their approaches, they would unlock the fence. They would first unlock the fence to have access to the site. They would then unlock the fence to get into this specific well that they're visiting. So that's the layout proposed system. So in the center of this site, we've proposed this third well, which we call VR3, and it has further to the right its own blow-off pond. That would be fenced initially with this project. And then also on this site, the reason we purchased the second 1.25 acre property is for the construction of the dual zone pump station that can transfer water from the Smith line back up to Quartz Hill and back from Quartz Hill. But that pump station, while it's been designed by AVEK, it's in the next phase of your construction CRP. So that's probably several years in the future. So right around the immediate well, there's the greatest drawdown, as you could imagine. And if you go to the street at West Avenue H, in front of the 2 wells on Bench Ranch, the 2 proposed wells on Bench Ranch, the drawdown is about 8 or 9 feet at the end of the year. So that's not a major impact, but that's what the model projects. Now, if you run it continuously for 4 years, there'll be more drawdown, and that's shown in this figure. And in this figure, at the same location along the street, the drawdown's more on the order of 16 to 17 feet. And it's, greater drawdown right at the wells. But as you move away from the wells, it quickly merges, it quickly levels out and matches the background water levels. So if you move about a mile on this figure to the east or to the north, you quickly see that the drawdown impact, even after 4 years of pumping, is only 1 or 2 feet. So there's not a great impact over a great distance. It's fairly localized. So with that, we were also asked to look at what the recovery would be after 1 year of pumping, after 4 years of pumping, and that's what's shown on this graph. So in the reddish brown color is the 1 year. You drop down to about 9 feet, you stop pumping, and it basically recovers over the next year and slowly over time. And then the same thing happens at this darker line. It runs for 4 years, and you see the drawdown reaches about 17 feet. And if you stop pumping, it recovers within the first year or two, and it's more slowly over time. So that's what the model projects for the recovery after those certain pumping intervals. So with that, in talking with the Water Projects Committee and developing the initial study for mitigating these drawdown impacts, we want to recognize that it's not the intention of AVEK to pump this in continuously and end up drawing down the basin to some great extent. The current water level is about 175 feet in the area, so it's proposed, AVEK's proposing as a mitigation factor to reduce or terminate pumping at the static water level as measured with the wells off after a day, and any of the 3 wells reaches 200 feet. So that's basically saying that you're not going to push the water table down by pumping continuously.
At 37%. We've started a new water year, so we got a clean slate, I guess, and we're a little above, looks like we might be just a little above average there. It's 2.7 inches. It rained a little bit in the watershed, and they've gotten somewhere between an inch and 4 or 5 inches up in Northern California. This is the 6 to 10 day forecast for precipitation. Looks like it might be a little above average for Northern California and below average for the central. This is, you know, the forecast. Yes. And this is the 1 month look, which is basically average rainfall for the next month or so. This is a
It should
reservoir.
be a lot better next year, shouldn't it? Because the new norm for average is going to be a lot lower.
Although they may throw that year out.
Maybe no more water.
Reservoir conditions, as I mentioned, Oroville's at 46%, San Luis is at 37%, and this has kind of been the problem, is that all these reservoirs are low, and it's going to take quite a bit to recover. This is the Oroville storage. Again, even though we got a little bit of rain, it's descending just a little bit, making releases for fish and so forth. So we got a long way to go in Oroville. San Luis kind of flattened out there. It's, again, very low level. Operations, again, you'll notice these, they've dropped just a little bit. Demands have dropped off just a little. Port Sill at 11, Roseman at 3.5, East Side at 1, and our Palmdale connection is at 1.5 MGD. Water bank extractions, we're continuing to do 7 acre feet a day at 96th Street, and we've got 12 MGD coming out of the bank. Any other operations? Water quality, we've got cooler weather, and you know, I can't say the water's improving, but we haven't had quite the issue with water quality. And we're back, you know, we were watching Mark Resistant pretty closely, and we were testing, I think we were testing every week there for a while, and then we skipped to 2 weeks, and we've gotten down to non-impact on that. So we're going to discontinue testing. I don't know, anything else on water quality measures? Water banking, aqueduct pumping still continues, 96th Street, and 12 MGD as I mentioned, and ag wells going to north to get customer tanks. State Water Project, there's an operations workshop that Dwayne and Tom will be going to. It's kind of a kickoff of the water year. We do a 2-day workshop, including a tour up in Sacramento, kind of talk about operations for the coming year. And so at that time, the Department of Water Resources, Reclamation, and the water contractor sat down with Beaver County and kind of came up with an agreement. This is an agreement that goes until 2025, and we have participated in the agreement up to this point. And what it does is it yields you a little bit of water in dry years, dry years. It's been a source of water for us. What they do though is each 5 years they kind of talk about the provisions and renegotiate the price and so forth. The current pricing will expire in September of next year, so we're good through this year and part of next year. We did actually get some Yuba water this year, and it's structured to where we can kind of pick how much water we want to pick at what price. There's 4 different components, and you can select those. The first 3 components are fairly reasonable. They average, in the past, they've averaged about $148 an acre foot. The new price, the proposed amendment, will raise the price some. In those prices will be effective from 2015 to 2020. Again, this is an agreement where you have kind of a lot of flexibility. If you don't need the water that year, you don't have to buy into it. If you want the cheap water and not the expensive water, you can do that. So, participation is optional. You don't have to. Once you're in the agreement, then you don't necessarily have to buy water every year. But we have exercised that opportunity in dry years. The maximum supply per year is 200,000 acre feet. What's different between Amendment 5 and what we've done in the past is this year they wanted a $20 million deposit. And basically what it is money up front that you would apply to future purchases. So if you put the $20 million down, that would, if you buy water into the future, if you have a dry year, you can use part of your deposit money for those purchases. 20 million is the total, so AVEK would have just a piece of that deposit. So it's, and what you would do if you put money down on the deposit is you would avoid kind of the annual fee. There's an annual fee that, and basically the annual fee is paying the interest on the 20 million to the people who put the money down. So if you contribute to the deposit, then you don't have to pay the interest. So it's a fairly flexible agreement. It gives you an opportunity to go each way. And if you think that you're gonna have a dry between September 2015 and 2020, if you think you're gonna have one dry year, one critical year, you're probably gonna pay for this pretty quickly. If you think you're gonna have 5 wet years that year, then you might not want to participate in this. So the options for the board tonight, and I did brief the finance committee on this in a little more detail, is we could decide not to participate in this program, and we may be able to get water other places, but this is a good source of dry year water for us. We could participate but not chip in on the deposit, and we would have to pay an annual fee to cover the interest that other contractors have put down on the deposit. Or we can participate, put down basically a deposit, which would be up to $528,681, and that's allocated based on Table A. This is one of those areas where AVEK has an advantage being the 3rd largest contractor because this water is allocated to contractors based on their Table A if they want to participate at that level. Again, you don't have to use all that. You don't have to use all of that deposit money in any one year, or you can use it if you have a really critical year and there's water available, you could use it right away. And again, this is water that is applied to future purchases, so and you would avoid those